All right, so let's continue with where we stopped in the previous video. So for this video, we are going to start calculate the values for the confidence interval. All right, so if you refer to our notes, you will see that there are a few cases here. So I put it under case number 1, case number 2, and also case number 3. All right, so I just want you to have a look. What is the difference between case 1, case 2, and case 3? And then in our discussion later about the example, I will try to show you how to tackle all the questions, because all the questions will look very, very similar. All the cases, okay, will look very, very similar. Okay, so you have to read very carefully when you trying to answer the question. Okay, so no matter how, we start with case number 1 first. Okay, so for case number 1, you know that your population is normally distributed. So I think I told you before, right? When any variable that is normally distributed, for sure, 100% guaranteed that you will see the word normally distributed in the question itself. All right, if they didn't mention the word normally distributed, that means it is not normally distributed. So that's the first, how to say, first thing that you need to know for case number 1. Okay, so second one is the population variance is known. So population variance is known. And then the third one, the sample can be any size, either large size or small size. Okay, so this is all the characteristic for case number 1. Yeah, all right. Then when they want you to calculate the confidence limits or confidence interval, generally you'll see that they are the same. Okay, just that for confidence limit, they write everything in one formula. So this one is plus and minus. That means got two values. One is plus, one is minus. And then for confidence interval, they just put it in the bracket form. So this is minus and this is plus. So the formula is sample mean minus Z multiplied with sigma over square root n. So you should know that sigma will be the population variance. All right, and then the n will be the sample size. Okay, all right, so the confidence limits and also the confidence interval, generally the formula are the same, just that the way that they write up is different only. Okay, then after that, there's another thing that you need to know when you want to calculate the confidence interval. They sometimes I will ask you to find the width of the interval. So the width means that what is the distance between value A and B. Okay, so this is the width. So to get the width, is actually the value B minus the value A. All right, so if you use the formula of B, then minus the value of A, the formula of A, and now you'll get the formula 2Z sigma over square root n. So you can see that this is what we have for the formula of the width. So some students, they will go and memorize it. So if let's say you found that you don't want to waste your memory space in your brain, then you can just know the idea. You just take the formula B minus formula A, and that's why you can get this correct formula here. Okay, so this is for case number 1. So of course later I will tell you in the question how I know that the population is normal, how I know that the population variance is known, and so on. Okay, so this is what you have for case number 1. All right, so if let's say we proceed to case number 2, for case number 2, what the characteristic for the cases are, for this case number 2 is the population is not normal. That means in the question itself, you didn't see the word normally distributed. Okay, but the population variance is known. That means you still know the value of the population variance. Because if the sample size is large, that means the sampling distribution, the sample is normally distributed, right? Okay, so these two are actually tagged together, right? If it is not normal, then you have to ensure that the sample is large. Therefore, so that the sample is normally distributed. Then for case number 1, because the population is normally distributed already, so no matter what kind of sample, large size or small size are you having, then it doesn't matter. All right, so both of them have one same case here, which is you must make sure that you know the population variance. All right, so if you look at it, the formula and everything is still the same like case number 1, just that all the rules here are slightly different, that the rules and regulations is slightly different. Okay, but the formula, everything is still the same when you want to apply it for the calculation. So this is the case 1, what we have for case 1 and case number 2. Okay, so if I proceed to case number 3, all right, so for case number 3, there's one very big difference between the case 1 and 2, which is the population variance is unknown. So this is the most important thing. Okay, and then you have to, of course, make sure that the sample size is larger. All right, okay, so if let's say, again, your population is normal, then any size. If population is not normal, then you have to make sure that the sample size is large. So for this case, it is a bit special because one of the rule is your population variance, you don't know what is the value. Okay, so when you want to calculate the confidence interval, you need the population variance, right? But now you don't know the population variance. Therefore, you have one extra step here. You need to do the unbiased estimate for population variance first. Then after that, only you substitute the S into your calculation. So you can see that in case number 1 and case number 2, because you know the population variance already, so you can straight away apply it in your calculation. But for case number 3, because you don't know the population variance, therefore you need to calculate the unbiased estimate for the population variance first. After that, you use that value that you calculate and substitute it into your calculation for confidence interval. All right, so these are the 3 cases that we are having. Okay, so for now, maybe we can take some time to discuss some of the examples. So at the same time, I will try to explain to you how I know which question is belongs to which case. Okay, all right, so let's have a look for example 20. You can read through it first before you start. Okay, so maybe first I want you to highlight the word normally distributed and then standard deviation 0.042. Okay, so for this first sentence, maybe I will put it in red color. Okay, then after that, for the second sentence, you will see that the mean mass of the vitamin E in a random sample of 5 capsules was 5.12. Okay, so when you read this question, there are 2 sentences here. First sentence is in red color, second sentence is in the bracket of purple color. Alright, so now for the second sentence, if you read through it again, they are talking about mean mass. Okay, and also a random sample. So that means for this second sentence here, they are talking about a sample. So all the values here will be the value for sample. So as an example, they say the mean mass. So mean mass means the sample mean. Okay, and is equals to 5.12. So from the second sentence here, you can get this value, the sample mean. And after that, they say 5 capsule. So 5 capsule here telling you that this is a sample size, which is equal to 5. Okay, so from this second sentence about the random sample, you can get 2 values about the sample, which is sample mean and also the sample size. All right, and then for question number 1, for the first sentence, okay, if you read through it, they didn't mention anything about sample, right, in the red color, red bracket sentence. So generally, they are talking about population. So from here, you can see that the population is normally distributed. You see the keyword, right, normally distributed. So they tell you here the population is normally distributed. and the standard deviation is 0.042. So red bracket is talking about population. That's why the standard deviation is the population standard deviation, which is 0.042. Okay, so you know the population standard deviation, which means you also know the population variance, because you square the standard deviation, you get a variance, right? All right, so this will tell you that your population variance is known. Okay, all right, so it belongs to case number 1 because population is normal, population variance is known, and then the third one is the sample size. So sample can be any size, no matter is it big or small. So in this case, it is a small sample size. All right. Okay. So once you identify everything already, you know that it is case number 1 already. Okay. So you can start now. Calculate a 95% confidence interval. Okay. So first, they want you to calculate 95% confidence interval. So usually for me, I will just write out like that. Okay, so what is the formula for 95% confidence interval? So the formula will be sample mean minus the Z, that's sigma over square root n, and also sample mean plus Z, sigma over square root n. Okay, so you just, very easy, you just need to substitute all the value that you know only. Okay, but of course, you need to know what is the value for the Z of 95%. Okay, so to save time here, I will not discuss it with you again, how to get the value of Z and so on. So I'll straight away apply the value. So for 95%, the value of Z is 1.96. So I substitute all the value. 5.12 minus 1.96. Okay, sigma is 0.042 divided by square root n, which is square root 5. So the same thing happened here, 5.12 plus 1.96. So this is what I have here. Okay, so you will see that actually to calculate this is not hard because once you know that how to put in all the value, then it's very easy. It is a very straightforward question. Okay, just you need to know what case it belongs to. Okay, all right, so we have done with part number 1. So part number 2, they want you to calculate the width of the confidence interval. All right, so we can start with the calculation here. So to calculate the width, I think I told you just now, if you can try to memorize. If you don't want, then you just use the concept to get the formula. So the width is 2Z sigma over square root n. So again, it is still a 95%. Z is 1.96. That sigma is the value that you get, 0.042 divided by square root 5. Alright, so from here again, by just pressing the calculator, you'll get the width, which is 0.0736. Alright, so this is what you have for part number 2. Very easy. Okay. Alright, then after that, we go to part number 3. You try to read the question first. Okay, so they are asking for, okay, I have 60 random sample of 5 capsules are taken and 95% confidence interval is calculated for each sample. So how many of this interval would you expect to not include milk? Okay, so for this one, it involves the concept that we covered in the first introduction video about confidence interval. So now, you see, when you calculate this one, right, this is one confidence interval. So you have one sample, so you calculate one confidence interval. So now you are having 60 confidence interval. So they are asking you how many of them might not have the mu. Okay, so I think I told you before, right? What is the meaning of 95%? So 95% means that 95% of the confidence interval include mu, right? That means the mu lies between the value. Okay, so which means 5% of confidence interval not include the mu. Okay, so now they said I'm having 60 confidence interval. How many of them do not include mu? So you just take 60 multiply with 0.05. So you get 3. So 3 will be your answer, which means out of the 60 confidence interval, you expect there are only 3 confidence interval that you calculate now does not contain, or maybe is out of the, how to say, the population value is not within that range. It's not within the interval. Okay, so this is how we do it. 60 multiplied with 0.05 equals to 3. The concept is very similar, like, okay, let's say I have 95% of students pass a paper. Okay, so now I'm having 60 students. How many of the students do not pass the paper? So you just take 60 multiplied with 5%, right? Okay, so this is the idea. Okay, it is just a common sense only, right? No specific formula, no specific rules to follow. It is just a common sense calculation, right? Okay, so this is what we have for example 20. I hope that you roughly have the idea here. Okay, so if no problem, we will continue to example 21. Okay, we can read the question also first before I start. Okay, so it looks like this is a long question, but never mind. Okay, so here they are talking about you can read first, highlight the word normally distributed, and then population you don't know how, okay? And then here they say you have a standard deviation 1.0, and after that you see the word random sample. So here maybe what I will do is that I will highlight, I will put a bracket with red color for this sentence, and then when they talk about the sample sentence, I will put a purple color. Okay. Alright, so from here you will see that again I ask you to highlight the important word normally distributed. So which means in this case they are telling you that this population is normal. Okay, and then because the red bracket sentence are talking about population, right? So from here you see they tell you that the standard deviation is 1.0. So the standard deviation here is actually the population standard deviation, which is sigma equals to 1.0. So if you have sigma equals to 1.0 means that for this case you know the population variance. Alright, so it fulfilled 2 rules already. The first one is population normally distributed. The second one is the population variance is known. And then what is the third one? We talk about the sample size. Sample size can be anything. So for this case, because you see the word a random sample, so the 65 here, very obvious, it is the sample size, which is equals to 65. No matter big or small, it doesn't matter for this case because our population is normally distributed already. Okay. Then after that, what else do they have? Okay, so maybe you can highlight the word mean mass again. So from here, they are talking about the sample, right? So the sample mean is x bar, which is equals to 29.6. Okay. Then now, once you know that, okay, you check all the rules here, and if you fulfill case number 1, so this is belongs to case number 1. Okay, so very easily, they want you to calculate a 99% confidence interval for mu. Okay, so 99% confidence interval. Okay, so what's the formula? Sample mean minus the z, sigma over square root n, and then sample mean plus z, sigma over square root n. Okay, so you just put in all the value very easily. So 29.6 minus the Z. So in this case, if you didn't do any careless mistake, your Z should be 2.576. Sigma is 1 divided by square root 65. Okay, then after that, you have also 29.6, then plus 2.576, then 1 over sigma 65. So again, I will try to press calculator and get everything into three significant figure. Then I will get 29.3 and also 29.9. So this is your confidence interval. So again, if someone asks you what is the meaning of this confidence interval, 29.3 and 29.9, that means they expect that the value of mean lies between these two values, which is 29.3 until 29.9. So maybe the mu can be 29.4 or whatever, all right, which is between these two values. Okay, but is it 100% that the mean is between these two values or not? It is not. We are only 99% confirmed that the mean lies between these two values. So that's the meaning of the confidence interval. So I hope that you, besides the calculation, you actually understand the meaning. All right, so we just want to know for our population variance, roughly what is the value. So you, from here, you know that it is 29.3. It will be 29 between 29.3 until 29.9. Okay, but it is not 100% correct one. Okay, but we only have 99% sure about this. Okay, all right. So let's continue to part 2 and part 3. Okay, so this question, they are asking more on the how to say concept question. Okay, so here they say there's one manufacturer claims that the machine produces sweets with min mass of 30. Okay, so now there's one manufacturer tells that this machine actually the min mass produced shouldn't be 29.6 like what they mentioned before. It should be 30. Okay, but the 29.6 they're talking about a small sample, the sample with 65 sweets. Okay, but now for this manufacturer, they are talking about the machine. So this machine produces sweets with a min mass of 30 grams. So which means they assume that the population mean should be 30. Okay, so now they want you to use the answer in part number 1. Okay, to draw a conclusion about this claim. So that means they are asking you the manufacturer state this sentence, the machine produced the sweets with min mass of 30 grams. So is this sentence, is this claim correct or wrong? Okay, so when they want you to check a claim, whether is it correct or wrong, there are a few ways. The first way is using the confidence interval. The second way is by running a test. So for running a test, we are going to learn it in chapter 5. Okay, we are going to do all the tests in chapter 5. But for now, because we only learn the confidence interval, right? So we can use the confidence interval to decide whether the claim is true or not true. Okay, so they are talking about 30, right? But if you look at the confidence interval that you calculate just now, is 30 lies between 29.3 or 29.9 or not? It is not. So from here, very obvious, you can see that the confidence interval does not contain, contain 30, the value of 30. So that means the claim is not supported. So the 30 here is some sort like your population mean. They assume that the population mean is 30 and they are asking whether is this correct or wrong. So by using the confidence interval that you calculate, so you can say that the claim is not supported. Okay. All right, so what else do we have for the third part? Okay, so now I have, sorry. So now I have a sample of 75 sweets produced by the machine. So just now I have one sample with 65 sweets, but now I have another sample with 75 sweets, and then this sample gives a 99% confidence interval that leads to a different conclusion from that found in part number 2. Okay, so that means now you have another sample and you calculate another confidence interval. So this new confidence interval maybe is A and B. And then they say now the 30 lies between the A and B already. Okay, so they are asking you how can it be? Because you are having, how to say, you are still calculating the 99% confidence interval, right? Okay, but why for the first confidence interval, the claim is not supported? But for now, the second confidence interval that you calculate now, okay, the claim is supported already. So they are asking you, how can this be possible? Okay, so now again, to explain this one, I need to refer back again to the formula here. So this is the formula when you want to calculate the confidence interval, right? Okay, so if they are talking about 99% confidence interval, the value of Z will not change if you compare it with the first confidence interval in part number 1. Okay, so the Z value is still the same. The population standard deviation is still the same value. Okay, so now you can see that the difference is what? The difference is the sample size, because in the first part, the sample size, okay, is 65, but now it's 75. And then for the sample mean, although you didn't calculate it out, but by right, you should know that the sample value sample mean value should be different also, because one sample is with 65 sweets. So you calculate their mean. And then for now, for this one, you're having 75 sweets, and you calculate the mean for these 75 sweets. So very high chance that you won't get the same value for the sample mean. So because of these two values are different, therefore the confidence interval that you calculate is also different. So that's why it leads to the different conclusion. Okay, so you can write that the sample mean and also the sample size values varies. Varies means that different, okay, from part 1, from, you can write part 1 first sample. And this one makes you get confidence interval with different value. Okay, and end up it leads to different conclusion. Okay, so for this part, this question itself, they are testing more on understanding. All right, so this is what I worry about. So because for recent years, they are asking more and more questions about the concept. So you need to roughly know how to elaborate your answer. Not to say write out very long answer, just like some basic idea, some basic sentence or simple sentence to explain the concept that they want to know. Okay, all right, so this one I have example 21. All right, so if we proceed further, I think example 22, I will want you to try on your own. Maybe you can try to figure out and see whether you know or not why it belongs to case number 1. Here I already highlight for you. Okay, I already mentioned it here. It is case number 1. But when you try to read the question, right, assume that you don't know it is case number 1. How you know that this question belongs to case number 1? So if this is something that you need to practice. Okay, all right, then I'll just give you all the answer for the part here. Part number A, they want you to calculate a 95% confidence interval. So first, you need to calculate the sample mean first, which is 106.638. And then after that, the confidence interval, 95% confidence interval, it should be 106.0 and then 107.3. Okay, then for part number 2, the answer is 10. How to get a 10? You go and figure it out. All right, so this is what we have for example 22. The calculation part, I think is very, very easy, not hard at all. All right, so for this video, I will stop here. Next video, we will discuss case number 2 and case number 3